Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. The numpy library in Python is widely used for numerical computations, and one of the powerful features it offers is the ability to compute gradients. The gradient of a function gives you the direction and rate of the fastest increase of that function. In numpy, you can compute gradients using the np.gradient function. What is np.gradient? The np.gradient function computes the gradient of an array. It returns an array of the same shape where each element is the gradient at that point. The gradient is computed using central differences in the interior points and first differences at the boundaries. Syntax. F. The input array for which the gradient is computed. *varargs, spacing between points along each axis, optional. Quargs, keywords for specifying axis, etc., optional. Basic example. Let's create a simple example to illustrate how to compute the gradient of a function. Example 1, gradient of a 1D function. Explanation. One function definition, y equals sin, x, is defined over a range of x values. 2. Gradient calculation, the gradient is computed using np.gradient, y, x, which gives the derivative of the sine function. 3. Plotting, the original function and its gradient are plotted side by side. Example 2, gradient of a 2D function. Now, let's compute the gradient of a 2D function, such as a Gaussian function. Explanation. One Gaussian function, a 2D Gaussian function is defined. 2. Mesh grid, np.meshGrid, creates a rectangular grid out of the x and y arrays. 3. Gradient calculation, the gradient is calculated using np.gradient, which returns the gradients along the x and y axes. 4. Plotting, the original Gaussian surface and its gradient vector field are plotted. The quiver plot visually represents the direction and magnitude of the gradient. Conclusion. The np.gradient function is a powerful tool for calculating gradients in one or more dimensions. It's particularly useful in fields such as physics, engineering, and data science, where understanding the rate of change of functions is crucial. This tutorial covered both 1D and 2D examples, demonstrating the flexibility of numpy for numerical computations.